Hi everyone, I'm Harsh Pathan and today I'm going to explain what are the properties of a pure substance. So before getting into the properties of the pure substance, first we need to know what is a pure substance. So what is a pure substance? Pure substance has a uniform and unchanging composition and it can be either chemical elements, compounds or crystals. In thermodynamics, air can be treated as a pure substance and it has three phases solid. So, phases of a pure substance. There are three phases solid, liquid, and vapor or gas. During the phase change process, the substance absorbs or releases energy, but its chemical composition remains unchanged. That is because of the pure substance. Then we can take the example of the boiling water. As heat is added, liquid water reaches its boiling point at 100 degrees Celsius at 1 atmospheric pressure, and it begins to change into the stream. And this is the example of the pure substance. And as we go into the detail of thermodynamics, we need to know the key properties of the pure substance. So most important properties or the key properties are pressure, which is force per unit area, temperature, which is the measure of thermal energy, specific volume, which is volume per unit mass, or we can write as density is equal to 1 over specific volume, internal energy, enthalpy, and entropy. Now the property diagrams. First is pressure versus temperature diagram. Here we can see uh, there are three phases: solid, liquid, and gas, and the point where all the phases meet or interact or connects, that point is called triple point. And the point where the liquid and gas phase are about to mix is called the critical point. And when the liquid is superheated, it's supercritical fluid. And here as the temperature versus specific volume diagram, we can see it's the saturated liquid phase, saturated vapor, and vapor. So the critical point here is means that the point that the phase is going to the superheated phase after the critical point. And this helps us visualize the phase change process. Saturation and superheated state. Saturated state. A substance is in a saturated state when it is at the point of phase change, either about to vaporize as the saturated liquid or just starting to condense as the saturated vapor. For example, at 100 degrees Celsius and 1 atmospheric pressure, water begins to boil. It is in a saturated liquid state. And as for superheated vapor, a superheated vapor is a vapor that exists at a temperature higher than its saturation temperature at a given pressure. As we saw in the last diagram, it was pressure versus specific volume. We saw the superheated state, and it means the substance is completely in the vapor phase and not close to condensing. For example, if steam at 100 degrees Celsius is further heated to 120 degrees Celsius at 1 atmospheric pressure, it becomes superheated. And it is also the same as the compressed liquid as we saw in the diagram. A compressed liquid is a state of pure substance when it is not about to vaporize, that it is it's a liquid at a temperature lower than its saturation temperature at equilibrium pressure. And the quality is the ratio of the mass of vapor to the total mass of the mixture of liquid and vapor, and it is also dimensionless. And the conclusion: pure substances are important in many real world systems like power plants, fridges, and engines, and they have a constant and uniform composition, and which helps in predicting their behavior. Pure substances play a big role in making modern life comfortable and technologically advanced. Thank you.